Hey, how's it going? My name's Aiden. I'm an engineering major at Texas A&M University, and I'm going to be showing you how to do integration by parts. So if you're an engineering major like me, then you're probably doing a lot of calculus or you're taking courses that require calculus. And if that's the case, then I think this video is going to be pretty useful for you. So the first thing I'm going to do is write down an integral, the integral of x e to the x dx. And if you're going to solve this using calculus 1 knowledge, which I'm assuming you already have, then you're probably going to use u sub, but u sub doesn't work for an integral like this. And this is where integration by parts can come in. So I'm going to show you two different ways that you can do it. First is going to be with a formula. And that formula is going to be the integral of function u d function v equals uv minus the integral of v du. And we're going to solve the same integral, so the integral of x e to the x dx. So what you want to do is determine the u, the du, the dv, and the v. And I'm going to determine what u is first. And just a side note, whenever you determine u, dv has to be the rest of the stuff in the integral. So in this case, I'm going to use x for my u, and my du is just going to be dx. And then again, dv is the rest of the stuff in the integral, including the dx. So that's going to be e dx dx. And then v is the integral of this, which should just be e dx. So now that I have all my terms, I'm going to put it all in the formula. So I'm going to rewrite the integral of x e to the x dx. And that's going to equal u, which is x, dv, which is e to the x, then minus the integral of v, which is e to the x, du, which is dx. So now you have an integral that you can solve. This is just going to be e to the x. So I'm going to rewrite the integral again. The integral of e to the x, x times e to the x dx is going to equal x e to the x minus e to the x. And if you're using indefinite integrals, then you're going to put a plus c, and that's going to be your answer. And if you're going to use definite integrals, then your formula is pretty similar. The only thing that changes is you're now integrating from different bounds. So it's going to be the integral from bounds a to b of u dv is going to equal uv. And you're going to evaluate this from a to b, then minus the integral again from a to b, and then v du. So that's what it would look like if you're doing definite integrals. So this is one way to do integration by parts. And the next way is going to be with a table. This is called the tabular method. So what I'm going to do is do a table. And I'm going to put d on the left, I on the right. And you always want to put d first and then I. And we're going to solve the same integral. So the integral of x e to the x dx. So what you want to do is you want to determine which value to differentiate, which value to integrate. And whatever value you choose to differentiate, you want to choose a value that differentiates to 0. So I know that x differentiates to 0, so I'm going to put x here in the d column. And then e dx is going to be in the I column. Again, you're not going to use d to the x in this one. And then you're just going to differentiate downwards from x. So the derivative of x is 1. The derivative of 1 is 0. The integral of e to the x is just e to the x. And then it's going to be e to the x again. And then now you're going to put alternating pluses and minuses starting from the first term. And lastly, you're going to multiply the two diagonal terms going from down to the right. And I'm going to rewrite the integral real quick. So it's going to be the integral of x e to the x dx. It's going to equal positive. So this is going to determine which sign to put before the term. So positive x times e to the x. And then minus 1 times e to the x, which is just e to the x. And then when you get here, you can't multiply diagonally. So you're just going to multiply horizontally. And when you do that, you actually want to rewrite the integral. So it's going to be plus the integral of the two terms, so 0 times e to the x dx. And the reason why you want to differentiate to 0 is because when you do that, this whole term ends up just being 0. So now if I rewrite it, it's going to be the integral of x e to the x dx is going to equal x e to the x minus e to the x. And then again, this is 0. And we're doing indefinite integrals, so this is going to just have a plus c at the end. And that's your answer. And as you can see, they give you the same answer. And if you're doing definite integrals right here, then you would just take your answer and you would evaluate it from b to a, or from a to b. So x e to the x dx. So you would take your answer, x e to the x minus e to the x, and again, you would just evaluate that from a to b. So that's how you would do integration by parts, using the formula in the tabular method. And I hope this helps, and thank you for watching.